Welcome to next lesson in AC circuits. Here we will discuss the remaining section of the last class. Series resonance circuit and quality factor. In the last class we have discussed the passage of AC through a series LCR circuit, and we found that the peak value of current in the circuit is I0 equal to E0 by root of R square plus omega L minus 1 by omega C whole square, where the quantity in the denominator can be represented by Z, which is called the impedance of the series LCR circuit. From this expression, we see that the impedance of the series LCR circuit and thereby the peak value of current depends on the omega. Omega is the angular frequency of AC. So the angular for very small and very large value of omega, the quantity omega L or 1 by omega C will be very large. For example, if omega is 0, then 1 by omega C will be infinity, and therefore this quantity will be infinity, and E0 by infinity will be 0. Therefore peak value of current will be 0 when omega is equal to 0. And if omega is equal to infinity, then the quantity omega L becomes infinite, and again the peak value of current will be 0. So the peak value of current I0 will be very small for small and large value of the angular frequency of AC. Now for a particular value of omega, when omega L becomes equal to 1 by omega C, this quantity omega L minus 1 by omega C becomes 0, and denominator becomes minimum. It will be equal to root of R square or R. Therefore, in that case, the current passing through the circuit or the peak value of current becomes maximum. So this frequency at which the inductive reactance and capacitive reactance cancel each other and current amplitude in the series LCR circuit becomes maximum. That frequency is called a resonance frequency, and the property is called a resonance in series LCR circuit. So at resonance, the resonance happens when omega L becomes equal to 1 by omega C. So this happens at a particular frequency omega 0. Therefore we can write omega 0 L is equal to 1 by omega 0 C, or omega 0 equal to 1 by root of LC. Or in terms of the normal frequency, the resonance frequency F0 is equal to 1 by 2 pi root LC. So if the frequency of AC is equal to the resonance frequency, then the peak value of current in the LCR circuit will be maximum. That is equal to E0 by R. If we draw a graph between the angular frequency omega and peak value of current, we get a graph like this. The peak value of current will be increasing as omega increases, and it becomes a maximum at the particular value called omega 0, called the resonance frequency. After that, the peak value of current again decreases. So this series resonance circuit, it is called resonance because when the frequency of the applied AC becomes equal to the natural frequency of the resonance circuit, then the current amplitude in the circuit becomes maximum, or the circuit accepts that current to a maximum extent. Or in another way, we can say that the series LCR circuit can accept a particular frequency from a group of frequencies. So they can be used for selecting a particular frequency, or they are used in the selector circuit of tuner of radios. Next one is the concept of quality factor. Quality factor is a quantitative number, which is a dimensionless number which represents the quality of resonance. If quality factor is very high, then that circuit has a sharp resonance. If quality factor is very low, it has a flat resonance. Then quality factor is defined as the ratio of voltage drop across inductor or capacitor at resonance to the applied voltage. Now at resonance, applied voltage will be equal to the voltage across the resistor, because at resonance the voltage across capacitor and inductor are equal and they are having a phase difference of 180 between them, so they will cancel each other. Therefore, the applied voltage will be equal to the voltage across the resistance R. Therefore, quality factor can be written as Q is equal to omega 0 L by R, or Q is equal to 1 by omega 0 CR. Actually, this is omega 0 L into I by R into I. I and I gets cancelled. Now, putting the value of omega 0 as 1 by root of LC, we get the quality factor as 1 by R into root of L by C. So this is the quality factor in terms of R, L and C. From here we see that the quality factor is inversely proportional to the resistance of the LCR circuit. In the ideal case, if the resistance of the circuit is 0, then the quality factor Q will be infinity. In that case, the peak value of current at resonance will be infinity, because I0 will be equal to E0 by R and R will be equal to 0. It is infinity. That is only an ideal case. So that it will be very sharp, infinitely sharp. And if quality factor is very high, it means that this R is very low and the peak value of current will be very high at resonance. So the second graph represents the sharp resonance. And if quality factor is very low, then it will be a flat resonance. There will be no pronounced hump in the graph. So the selector circuit, the high quality factor circuits will be, they are suitable for selecting a particular frequency. So their selection criteria or their selection ability will be very high. They can select a particular frequency only. So in radio receivers, inside the tuner of the radio, we will be using the LCR circuit with high quality factor of the order of 10 or above. So they can have the ability of selecting a particular frequency. So thank you for watching this.